Welcome back to the Aspen PIMS How-To series. This video will walk through the main tables that you will modify. There are 11 main tables within a model where you will make most changes. These tables are supply-demand tables such as buy, util buy, sell, util sell, capacity constraints in table caps, process or property limits in table proc-lim, 4 blending tables, including blends, blend spec, blend mix, and blend prop, and defined starting property guesses in table pguess. As a user, your main responsibilities will be modifying these tables and the case table which we discussed in the previous video. The modification of these tables are all done in Excel. While making modifications, make comments for other users. You can use the asterisk to start the row, and this will make the entire row a comment. For columns, use an exclamation point, and this will comment out the entire column. Another important note is that PIMS will not read any column after there is a column with an asterisk. To understand the headings for each of the tables, right-click on Model Tree and select Context Sensitive Help. This will take you to the help system, which has information on what the columns mean, as well as an example which you could copy and paste into Excel to use as a starting point for your model. The rest of this video is dedicated to the individual tables themselves. The first table we will learn about is the buy table, which is in the supply and demand section. Select buy and double-click to open the attached spreadsheet. The table buy contains all the materials that are bought in a model. The first column corresponds to a 3-character name that you define. All names, including capacities, streams, qualities, and submodels, must have only 3 characters in length. And these names are case sensitive. Some tag names are reserved and cannot be used for other variable names. The 3-character names are used to transfer a stream from one unit to another in the model, and to assign assays to that crude stream. You can then specify the min and max amounts for that material, or fix a certain amount by setting the min and the max equal. Many new users make a mistake here using the wrong units. The min, max, and fix columns are in units of kilobarrels per day. In other words, they have to be scaled down by 1,000. You should also define the cost of the purchase. You can also specify groups which are useful for showing subtotals in the standard reports. For example, all the sweet crudes can be subtotaled together if you put them in the same group. Then add in specific gravity or API for each crude. This is important because the assays do not include whole crude properties, rather just properties of each cut of the crude. There is also a column called I-price, which is the infeasibility price. This is the value at which the model can sell the purchased material if it is unable to process all of it. This feature is used to avoid material imbalance or infeasibility. We'll cover more about model infeasibilities in a later video. Table util buy is very similar to table buy, except it contains all the utilities that can be consumed by the plant. For example, electricity or steam. The utilities can be defined in each submodel, so each unit consumes a separate amount of utilities. Table sell contains all the products which are sold in the model. The first column corresponds to a 3-character name that the user defines. You can then specify the min and max amounts for that material or fix a certain amount by setting them equal. You should also define the price of the sale. You can also specify groups, which is for reporting purposes. There is also a separate column called I-cost, which is the infeasible cost. This is the value that the model can use to purchase additional material, similar to the I-price for the buy table. The I-cost should be higher than the normal price of the product. One further detail on this, as many new users make this common mistake. Cost is the price you pay to someone else for something you buy as a feed, like the cost of Arabian light crude. Price, on the other hand, is the price paid to you for something you sell as a product, like the price of diesel made in your refinery. Many new users make a mistake when creating the sell table, just copying over the column heading cost from the buy table into the sell table. Having the wrong column titles will cause problems when running the model. The last supply and demand table is table util cell, and it is very similar to table cell. It contains all the utilities that can be sold by the plant. The caps table, which is under submodels in the model tree, allows the user to enter capacity constraints for each unit. This is specified in two places. First, in the caps table, the min and max limits are defined. And second, that variable will be defined within the submodel that you are constraining. Notice that the caps table has the name starting with the letter C, and in the submodel table, the variable now begins with C cap. Handling submodels is a complex topic and will be covered in several videos later in the series, but we wanted to introduce it here. The proc lim table is similar to the caps table and is also in the submodels branch of the model tree. Proc lim imposes limits on process conditions, just like caps controls unit capacities. Caps are flows or activities, whereas proc lims or process limits are properties of pools or blends, such as their sulfur content, very similar to a blend spec. In table proc lim, the user can set max or min constraints, and the variables start with the letter Z. Each proc lim must have a corresponding entry in a submodel. The variable in the submodel will begin with Z lim. Details of how to set up proc lim within your submodel will also be discussed in a separate video. There are four main tables under the blending section: blends, blend spec, blend mix, and blend prop. They are all under tables and then blending on the model tree. The blends table denotes if the blend is a spec blend or a formula blend. A 1 in the column named spec will make that blend a specification blend, while a 1 in the column named form will make that blend a formula blend. This is a common convention in PIMS, to turn on or off a characteristic using a 1 in a column. The blend spec table is used to define property specifications for a blend. For each blend, the start of the row either has an X or an N. An N denotes the minimum for that quantity, while X denotes the maximum for that quantity. The columns are all the specification blends in the model. The blend mix table contains, for a formula blend, the fractions of each component in a blend. For example, for the product LPG, it is made of 80% propane, it is made of 80 and 10% normal butane. And for a spec blend, or a specification blend, the blend mix table contains all the components that could go into that blend. If a blend is a spec blend, then you enable streams that can be used in that blend by adding the number 1 for each component. For example, the product UPR, unleaded premium gasoline, can be made from any combination of these blend stocks. The last thing we will discuss around blending tables is table blend prop. Blend prop is where all static properties for streams in the model are entered. The property values designated here will not change as the model is optimized. The pguess table, which stands for property guess, is also a table to be aware of in the recursion branch of the model tree. Pguess contains the initial guess of the calculated properties, for example, the properties of a pooled feed stream, for the solver to start from. A bad pguess can cause the model to get stuck in local optima. Most users only edit pguess when new structure is added or they are having convergence troubles. Then they hope to find values that allow the model to run stably. A best practice when setting up the model is to use unit data and engineering judgment to input accurate values in the pguess file to ensure it is as accurate as possible. For example, variable CFP is the cat feed pool, which is made up of different streams. The planner can work with the engineers to get data on that stream and thus define it as accurately as possible, using samples, lab data, or other simulations. Thank you for watching. If you would like more information, visit our website at www.aspentech.com and click on Products, then Petroleum Supply Chain.